to be graphing exponential functions. Using a table of values. So when you look at an exponential function, you're either going to see growth or decay. So if b is greater than 1 in the equation, you're going to see growth. And if b is between 0 and 1, or in other words, it's a fraction, you're going to see decay. And so growth is increasing and decay would be decreasing. So let's look at the different components of an exponential graph and work on creating a table. So a function would look like a times b to the power of x minus h plus k. So for example, we might have f of x equals 4 times 2 over 3 to the power of x plus 1. All right, so in this case, a is 4, b is 2/3. H is 0 because there's no subtraction from x, and then k is 1. So this is important. We need to know what k is because that tells you where your asymptote is. So we need to identify the asymptote, which is y equals k. So our asymptote for this function would be y equals 1. So then we're going to fill in the table. We're always going to start with the vertex, and the vertex will always have, sorry, not the vertex, the y-intercept. And we'll find the y-intercept because it always has an x value of 0. So all we do is substitute into the equation x equals 0 and find the y value, and that will give us our y-intercept. So in this case, we would do 4 times 2 over 3 to the power of 0 plus 1. Now you can put that in your calculator if you want to. I know that anything to the power of 0 is 1. So this would be 5. And then you fill in the rest of the table with 2 x values to the left and 2 x values to the right. And then you'll plug in those values, just like you did with the 0, to fill in the rest of this table. So if I substitute in, what color do I want to use here? -2 for x, using my calculator, I'm going to do 4 times 2 over 3 to the power of -2 plus 1. That will be 10. Then I can substitute in -1 for that exponent, and I would get 7. Keep changing that exponent to the x value. The next one's 1. And I would end up with 3.67. If your calculator, well, I'm going to keep it 6.6. If your calculator gives you a fraction, go ahead and convert it to a decimal, because I just feel like decimals are easier to plot on the graph. Personal preference. And then we have 2.77 for the x value of 2. So that is how you fill in the table, and then you would graph the function. So let's look at a new example, and this one we're going to actually graph. So looking at number 1, f of x equals 1/2 to the power of x. What we need to find is k. Since there's no number after x, k would be 0. So my asymptote is y equals 0. I'm going to actually put this in pink since that's the color I used up there. So my asymptote I'm going to draw at y equals 0. Now I need to find the y-intercept. Remember, put in 0 for the x value in the middle of the table. And now I'm just going to plug in that value to the equation. So in my calculator, I would do 1/2 to the power of 0. And that's going to give me 1. And now I choose 2 x's to the left and 2 x's to the right, and substitute in each of those values for x. So this will be 1/2 to the power of -1. That's a negative exponent. We'll just flip the fraction for you. So that would be 2/1, or just 2. Then I would do 1/2 to the power of -2. That would be 4. 1/2 to the power of 1 is 1/2. I'm going to convert that to a decimal. And 1/2 to the power of 2 is going to be 1/4. So now I have my points, and I can plot them on the graph. So my y-intercept is 0, 1. Then I have -2, 4. -1, 2. 1.5, so I'm going to kind of zoom in here. And at this point, you're just estimating. It's just going to keep getting closer and closer to the asymptote. Once I have 5 points plotted, I can see that this is going to be exponential decay because it is a fraction. That is what it's supposed to be. And I'll just fill in the rest. So this line, as it flattens out, will continue to get closer and closer and closer to 0 forever. Never ever actually touch y equals 0. My domain, oops, that's where my y-intercept goes, 0, 1. My domain is -∞, infinity, and the range is going to be 0 with a parentheses, not a bracket, because it will never actually touch 0 to infinity. Number 2, let's find the asymptote. So, oops, I meant to highlight that. K is 5. So my asymptote is y equals 5. Let's find the y-intercept by plugging in 0 to the equation. Two to the power of 0 is 1. 1 plus 5 is 6. So here is my y-intercept. Fill in the rest of the x's, and then we'll be plugging those into the equation. Two to the power of -2. And you'll probably need to put that in parentheses, the exponent in parentheses. Something is not working with my calculator here. Just 1 second. I think my batteries are dying. Okay, so if we substitute in -2 for 6, we're going to get 5.25. If you substitute in 2 to the power of -1 plus 5, you will get 5.5. 2 to the power of 1 plus 5 is 7. And 2 to the power of 2 plus 5 is 9. So here I'm just going to kind of get closer here. Just estimating on those decimals because it does get hard here. 0, 6, 1, 7, 2, 9. All right, so my y-intercept was 0, 6. The domain is -infinity, infinity. And my range would be 5, infinity. All right, number 3. We have 2 to the power of x plus 1 minus 2. K is -2, so my asymptote is going to be y equals -2. Let's find the y-intercept. 2 to the power of 0 plus 1 minus 2. And that's going to give me 0. So my y-intercept is 0, 0. Identify 2 x's to the left and 2 x's to the right of the y-intercept. And plug in -1 for x. 2 to the power of -1 plus 1 minus 2. And that's going to give me -1. And then 2 to the power of -2 plus 1 minus 2 gives me -1.5. 2 to the power of 1 plus 1 minus 2 is 2. And 2 to the power of 2 plus 1 minus 2 is 6. Okay. -1, -1, -2, -1.5, 1, 2, and 2, 6. All right, so my domain is -infinity, infinity, and the range is -2 with a parentheses, infinity. Last example. K is 2, so my asymptote is y equals 2. Y-intercept is 0 something, so let's plug in 0. That's going to give me 4. So 0, 4 is my y-intercept. I'm just going to write all of these out. Oops, -2 minus 1, that goes there. All right, so plugging all of those into the calculator. This will give me 10. This will give me 6. 3. And 2.5. All right, -1, 6, -2, 10, 1, 3, and 2, 2.5. All right, so that's what you'll be doing in today's practice for graphing exponential functions with a table.